So remember, we're going to spend today looking at these laws of exponents, continuing on what we learned yesterday. We'll do some more of this on Monday. On Tuesday, you guys have a quiz on everything that we have been learning about exponents. So remember day one, we talked about square roots, cube roots, applications of finding square root and cube root, and then also these laws of exponents. So we'll continue on with the laws of exponents. Question says, simplify each product or quotient. In the first one, 2 to the negative 3 times 2 to the 5. You're multiplying powers with the same base. The law says you add the exponents and you keep the base the same. Remember, we said that you use the other laws first. If at the end you end up with a negative exponent, then you deal with it then. But it's always good to wait till the end, because in this case, when you add the negative 3 and the 5 together, you actually get positive 2. So you no longer have a negative exponent once you use the product law. And in this case, you could leave it as 2 squared, or you could also say the answer is 4, because 2 squared, remember, means you're multiplying 2 by itself twice. Question B. Now you're dividing powers with the same base. The law says you subtract the exponents and keep the base the same. And negative 5 take away 3 is negative 8. But remember, you cannot leave an answer like that. You have to make the exponent positive. This is the same as 1 times 7 to the negative 8. And we do that because when you move the 7 down to the bottom, you cannot leave the top just blank. You need something there. And that's where that 1 comes in. 1 over 7 to the power 8. And you could definitely use your calculator to find out what 7 to the power 8 is. It's going to be a mighty big number, and then 1 divided by that will give you a very small decimal that you'd have to round, so I'm just going to leave it like that, 1 over 7 to the power 8. Question C is the same. You're dividing powers with the same base. Remember, the law says you subtract the exponent, and the other important part of that is that the base stays the same. So even though when you might look at this and say, well, I'm dividing a negative by a negative 3.5 by a negative 3.5. You're not. You're dividing negative 3.5 to the 4 by negative 3.5 to the negative 3. The law says you subtract the exponents and the base stays the same. It stays negative 3.5. And 4 take away negative 3, the minus minus becomes a plus positive. So it becomes 4 plus 3, which is 7. Are we done that one, Keen? Is that one finished? Why not? You need to multiply the 7 by negative 3.5. Is that what you said? You agree with him, Jan? No. You're done. Nothing else can be done. Remember, a negative base is not a problem. It's only negative exponents you have to worry about. There's nothing you can do to get rid of the negative base. So that one is done. Question D, again, dividing powers with the same base. The law says you subtract the exponents and the base stays the same. And a minus minus becomes a plus positive, so that really becomes an exponent of 2 plus 6, which is positive 8. And you need the brackets there. Okay, the original expression had the 3y in brackets, so you must continue to put the 3y in brackets. Without the bracket there, the power 8 would apply only to the y, not the 3, and that's not right. Okay? So on the next page, it says write each expression as a power with a single positive exponent, then evaluate where possible. So what do we do for question A? What do we do to those exponents? Chloe, what do you do to those exponents? I'm sorry? Multiply them. You agree with that, Cheney? Yes, because you have one exponent raised to another. So that becomes 4 to the negative 6. Is that one done, Declan? Why not? Right? This is the same as 1 times 4 to the negative 6, and we do that because the 4 to the negative 6 has to move from the top to the bottom. We can't leave the top blank. We need something there, so that's where the 1 comes in. Now it does say evaluate where possible, so we could use our calculator to find out what 4 to the power 6 is. 4,096, and leave it like that. Okay? Question B. Inside the square brackets, you're multiplying powers with the same base. They both have a base of 8. However, a to the 0 equals what, Brody? 1. So that's really a to the negative 2 times 1, or a to the negative 2 to the power negative 1. So that's where we're at right now. Now what, Sophia? And what happens to the base? Stays the same. So when you multiply a negative 2 by a negative 1, it becomes positive 2. No longer have a negative exponent to worry about. And because the base is a variable, we cannot evaluate that. We can't get a numerical answer for it because the base is a variable. Question C, I would probably work inside the brackets first. You're dividing powers with the same base of 2. The law says you subtract the exponents and keep the base the same. And 4 take away 6 is negative 2. So we have 2 to the negative 2 raised to the power negative 3. Cheney, what do we do to those exponents? And get what? 2 to the power 6. Which I think is 64. 2 multiplied by itself 6 times. Two to the power 6 is 64. Right, so there's the answer for that one. Question D. You're multiplying inside those big square brackets, you're multiplying powers together with the same base of 3/4. So what do we do, Brooklyn? Yep. Add what? And what happens to the base? Stays the same. So we're going to have 3/4, and you're going to add the negative 2 and the negative 2 together, which gives us negative 4. But then that's still raised to the power negative 2 that's outside. Now what do we do, Brock? Yeah, you could. I'm sorry, say again, I didn't hear you. Okay. Alicia, what do we do next? What happens to the base? Base stays the same. And negative 4 times negative 2 is positive 8. So again, use all the other laws first. If at the end you have a negative exponent, you deal with it. But in this case, we don't. So that one is done. So, more examples. Simplify each of the following. Do not leave negative exponents in your final answer. So for question 1, I would multiply the p's together by adding those exponents and the q's exponents together because you're multiplying powers with the same base. So first with the p's, it's negative 6 plus 2, which is negative 4. And then we have q to the power, the exponents on q are 4 and negative 2. So 4 plus negative 2 is a positive 2. So when you multiply the p's together by adding the exponents and multiply the q's together by adding the exponents, that's where we're at. Now, this is different than what we looked at yesterday because we have 2 factors. Factors are things that multiply together. The first factor is p to the negative 4. The second factor is q squared. One of those exponents is negative. We can't leave it like that. We have to make it positive. Now, I just want to show you something. Don't copy this part down. I want to show you, and then we'll go to a shortcut to getting the final answer. P to the negative 4 times q squared. This is what this means. Again, don't copy this down, just watch this. That's the same as p to the negative 4 over 1 times q squared over 1. You can take any number, any expression, put it over 1. You haven't changed it because dividing by something by 1 doesn't change it. Okay? But the reason I'm doing this is now we can deal with the p to the negative 4, which is 1 times p to the negative 4, and we can move the p down to the bottom. So it'll be 1 over p to the positive 4 times q squared over 1. And now you're multiplying a fraction times a fraction, so it's top times top, bottom times bottom. 1 times q squared is q squared on top, and on the bottom, p to the 4th times 1 is p to the 4. There's your final answer. Now, I showed you where it comes from, but you don't have to do this. Whenever you have factors like we have, and I'll circle this in black, whenever you have something like that, you can go straight to that answer. Whichever factor has a negative exponent, it'll move. In this case, from the top to the bottom. And you're done. You don't have to show those couple steps that we did in between. I showed you why that works, so now you can just do it every time. So we'll see some more examples like that as we go through these examples here. Okay, question 2. What do we do to those exponents, Jensen? You got one exponent raised to another. You don't remember what we do? No. We never divide the exponents. Never. If you're dividing powers with the same base, you subtract the exponents, but we never divide the exponents. Isn't it what? You got x to the negative 5 to the power 3. Well, that helps. I don't know, I'll play your silly game. Is it multiplication? Okay, man. Yes, it is multiplication. So you're going to multiply the negative 5 times the positive 3, and the base stays the same. So you'll get x to the negative 15. Are we done, princess? What do we need to do? And then write what? Say again? No, it's 1 over x to the 15. The 1 is not to the power 15. All right, now we're done. Question 3. In this case, the bases are not the same. So you cannot simplify inside the brackets. So we'll go to the next step where you have powers inside the bracket raised to the power negative 2 outside. The law says you multiply the exponents together and the bases stay the same. So on top, it's 5 times negative 2. That gives us x to the negative 10. On the bottom, negative 3 times negative 2 is positive 6, so we'll get y to the positive 6. Now, like I just showed you up in question 1, I need to make that x exponent positive by moving it from the top to the bottom. Again, this is the same as 1 times x to the negative 10, so the 1 will stay on top, and on the bottom, you'll have the y to the 6 and the x to the positive 10. You're done. You could put the x to the 10 first, the y to the 6 second on the bottom. When you multiply two things together, order doesn't matter. 2 times 3 is the same as 3 times 2. Order doesn't matter when you're multiplying. But we can just move the x down to the bottom so it becomes a factor of the bottom, and then the exponent sign becomes positive. Number 4. Olivia, what do you think the answer to number 4 is? 1? Remember, this is the same thing as 6 times p to the 0. The power 0 applies to the p only, not the 6. So it's 6, because the 0 applies only to the p. P to the 0 is 1 times 6 gives you an answer of 6. Question 5. I would multiply the coefficients together. Negative 5 times 4 is negative 20. Then I would multiply, well, there is an r in the first one, but there is no r in the second bracket to multiply. So the r to the fourth will stay the same. Won't change because I'm not multiplying it by anything with an r. But there's an s to the negative 3 times s to the positive 1. I can multiply those together by adding the exponents. Negative 3 plus 1 is negative 2. And then we have t to the negative 2. The t to the negative 2 in the second bracket is not being multiplied by a t in the first, so it doesn't change. Are we done, Emery? Why not? Where do you see a negative that we have to deal with it? On the s and the t, that's right. The negative 20 coefficient is fine. There's nothing we can do about that, and we don't have to. But yes, and all you have to do is just move the s and the t down to the bottom. I showed you earlier today, that's all you have to do, and I showed you why that works. You just move them both to the bottom, and then the exponent signs change from negative to positive. There's the final simplified answer. Number 6. What do we do there, Brock? Number 6. What do we do there? Number 6, we're dividing a to the negative 3 by a to the 4. When you're dividing powers with the same base, what do? Subtract what? And what happens to the base? Stays the same. So it'll be negative 3 take away 4. Which, if you need to use your calculator to do this, use your calculator. But negative 3 take away 4 is negative 7. Are we done, Emil? Why not? Negative exponent. This is the same as 1 times a to the negative 7. The 1 stays on top. The a moves to the bottom. Okay. Question 7. Divide the a's, divide the b's. What do we do to the exponents when we divide the a's, Brooklyn? So it'll be 3 take away 1, a squared. When you divide the b's, you subtract the exponents. Negative 2 take away 4 is negative 6. Are we done, Keen? What do we need to do? Right. Where it'll be a positive exponent. Now we're done. Again, I showed you earlier today why that works. You don't have to show those couple steps that I showed you. I showed you why it works, so you can just continue to do that. Question 8. I would simplify inside the brackets first. Negative 36 divided by 6 is negative 6. When you divide the q's, you subtract the exponents. 3 take away 5 is negative 2. When you divide the r's, you subtract the exponents. Negative 4 take away 0 is still negative 4. Again, you could consider that r to the 0 just to be 1. But then you'd have r to the 4, negative 4 divided by 1, which is still r to the negative 4. Do you have a question, Brock? You need help with something? You're okay? Now we will square everything inside the bracket because we have that power 2 outside. And includes the negative 6. Negative 6 needs to be squared. You're squaring both the negative and the 6, which will give you positive 36. And again, you can do that on your calculator. You just have to make sure that you put the negative 6 in brackets. Okay, so you have to put the negative 6 in brackets. Otherwise, it'll only square the 6 and not the negative. If you do it without brackets, it only squares the 6, not the negative. And that gives you a negative answer. You need to use brackets so that the negative and the 6 are both squared. So again, that gives us positive 36. And then all the exponents inside the bracket are multiplied by the power 2 outside. So negative 2 times 2 gives us q to the negative 4. Negative 4 times 2 gives us r to the negative 8. Now what, Cheney? Are we done? Why not? How do you make those negative exponents positive? Put them on the bottom. So the q will move to the bottom and become a positive exponent. Same as the r, moves to the bottom, becomes a positive exponent. Now we're done. Okay? Question 9. I would simplify inside the brackets first. D to the 3 divided by D to the 1. You subtract the exponents. 3 minus 1 is 2. When you divide the e's, you subtract the exponents. 4 minus 6 is negative 2. Same thing in the second bracket. I will divide the d's by subtracting the exponents. 2 take away 3 is negative 1. Negative 4 take away 4 is negative 8. And again, if you're not sure, use your calculator. But you have to remember, because you're dividing powers, you subtract the exponents. And now we will deal with the power outside the bracket by multiplying the exponents, right? Whenever you have one exponent raised to another, you multiply the exponents and the base stays the same. So that would look like that. And now we will multiply d to the 6 by the d to the negative 4. They have the same base, so we can multiply those together by adding the exponents. 6 plus negative 4 is positive 2. And when we multiply the e's together again, we add the exponents. Negative 6 plus negative 32 is negative 38. Are we done, Olivia? What do we need to do? Put the e in the bottom. And when you do that, the exponent sign changes from a negative to a positive 38. Now we're done. We've simplified that expression. Question 10. There's nothing inside any of these brackets we can simplify because the bases are all different inside the brackets. So we'll go to the next step, which is you have exponents inside raised to an exponent outside. You multiply those exponents. So for n, it'll be 4 times negative 3, which is negative 12. For m, that's m to the 1 times negative 3 is negative 3 times. Second bracket, n to the negative 2 times 2 is negative 4. M to the negative 1 times 2 is negative 2 times. And in the third bracket, it's n to the 4 times negative 1. M to the negative 2 times negative 1 is positive 2. Okay, Cheney, I need you to be focused to what I'm doing up here, okay? Thank you. So now we are multiplying. And we're going to multiply the factors together that have the same base by adding the exponents. So I got n to the negative 12 plus negative 4 plus negative 4. If I underline all of the parts that have the base of n, those are the exponents that we're going to add together. Negative 12 plus negative 4 is negative 16, plus negative 4 is negative 20. So now that's the n simplified. And we'll do the same thing with the m's. We'll add all the exponents. Negative 3 plus negative 2 is negative 5. But then we're going to add 2, so now we're back to negative 3. So that's where we're at. Are we done, Peyton? What do we need to do? Yeah, this is the same thing as 1 times all of that. The 1 stays on top. and both the n and the m move to the bottom, and there's your final simplified answer with positive exponents. You could switch those two around on the bottom. You could put the m first, the n second. It doesn't matter. When you multiply, order doesn't matter. Question 11. We can simplify inside the brackets first. You're dividing negative 2 by a positive 1. Right? There's no coefficient in front of the f and g in the bottom, which there's still a 1 there, though, technically. So that'll be negative 2. And when we divide the f's, you subtract the exponents. So it's 3 minus negative 3. The minus minus becomes a plus positive. It becomes 3 plus 3, which is 6. And when you divide the g's, you subtract the exponents. Negative 2 take away 4 is negative 6 to the power 3 outside. So now we need to cube everything inside the bracket, including the coefficient of negative 2. Negative 2 all cubed will give you negative 8. And you can do that on your calculator. In brackets, negative 2 to the power 3, that means multiplying negative 2 by itself 3 times, you will get negative 8. And then f to the 6th is raised to the 3 by multiplying the exponent. 6 times 3 is 18. Base stays the same. And then the g is negative 6 times 3, which is negative 18. So there's where we are. Are we done? Are we done, Brody? What do we need to do? Move the g to the bottom. The negative 8 coefficient is fine. There's nothing wrong with having a negative coefficient. There's nothing you can do or need to do. But the g needs to move from the top to the bottom so that that exponent becomes positive. There's the final answer. Question 12. There's no multiplying or dividing or one power to another power here. So we don't have to do any of that, but we have to change any negative exponents to positive. The coefficient of negative 15 is fine. The y is y to the positive 1. There's no exponent on it, which means it's positive 1. So those both stay on the top, but the x has to move to the bottom, and the z has to move to the bottom. Now that one is done. We made all the negative exponents positive. All right, looking at number 13. Technically, there's a 1 in front of the p, and there's a 2 on the bottom. Now, you cannot divide 1 by 2 and write anything different. It stays 1 over 2, or 0.5. Okay? But for now, the 2 is going to stay on the bottom as I work through this. I can divide the p's, though, because you're dividing powers with the same base. The law says you subtract the exponent and the base stays the same. So when you subtract the exponents on p, negative 3 take away 4 is negative 7. And same thing with the q's. When you subtract the exponents, it's negative 2 minus 1, which is negative 3. Remember we said that 2 is going to stay on the bottom, and that's all raised to the power negative 4. So now everything inside the brackets raised to the power negative 4. Okay? This 1, we could raise that to the power negative 4, but 1 to anything will just be 1. So I'm not worried about that. But The negative 7 power is raised to the negative 4, so you'll multiply those exponents, and that gives you positive 28. Same thing with the q, negative 3 times negative 4 is positive 12. But again, we can't forget we've got the 2 on the bottom, which would also be raised to the power negative 4. And that 2 to the negative 4, before I can evaluate that, I have to have the exponent positive. So in this case, I'll move it from the bottom up to the top. And it becomes 2 to the positive 4 on top, p to the 28, q to the 12. And 2 to the 4 is multiplying 2 by itself 4 times. That'll give us 16. There's the final simplified answer. That 2 was on the bottom. It was raised to the power negative 4. And that is on the bottom. Before we can evaluate that, we have to make the exponent positive by moving it from the bottom to the top, and you'll get 2 to the positive 4 on top. And if you use your calculator and you do 2 to the negative 4, it will actually do it. It'll give you, whoops, negative 4 there. It'll give you the answer. Hang on a second, I might have to put it in brackets. Negative. Oh, no, I know. It was 1 over 2 to the negative 4. That's why. Sorry about that. 1 over 2 to the power negative 4. Because the 2 was on the bottom. It gives you the answer of 16. It moves it to the top and then goes 2 to the 4th. Question 14. We can simplify a little bit because we have exponents inside the bracket, raised to the power outside. Cherry, what do we do to those exponents? Multiply them, and what happens to the bases? Stay the same. So this is x to the negative 5 times negative 2, which is positive 10. Y to the 4 times negative 2, which is negative 8. Z to the 3 times negative 2, which is negative 6. So when you multiply the exponents, that's where we're at. Yes, Jensen. As soon as we're done. Are we done, Ava? Why? And so what do we need to do? So which ones are going to move to the bottom? Because I asked you, that's why. Y and Z. I knew you'd like that, Keen. Well, don't do that, please. Okay? So there's the answer. Number 15, I'd work inside the brackets first to simplify. 15 divided by 3 is 5. Brock, put your phone on my desk, please. Pardon me? That's crazy? I shouldn't have to tell you every class to stay off your phone. I shouldn't. You're in grade 10 now. So act like it. You're here to learn. Okay? So when you divide the a's, you subtract the exponents. It's a to the 0, which again, if you want to say that's 1, that's fine. It's not going to change the answer. But if we use the law of exponents, you'll go 0 minus 1, which is a to the negative 1. And then when you divide the b's, same thing. You subtract the exponents. 4 minus 0 is 4. And that's all raised to the power negative 2. So that was step 1. Now I'll raise everything inside the bracket to the power negative 2 and outside, including the 5. When you raise a to the negative 1 to the negative 2, you have one exponent raised to another, so you multiply those exponents. And we'll get a to the positive 2. For the b, again, multiply the exponents. 4 times negative 2 is negative 8. So I multiplied the exponents inside the bracket by the -2 outside. So that's where we are. Are we done, Kenzie? What do we need to do? We need to fix the negative exponents. How do we do that? Put them on the bottom. So the only thing that's going to stay on top is the a squared. That has a positive exponent. That'll stay on top. Everything else will move to the bottom, including the 5, because we need that exponent to be positive. And then the b moves down as well. That exponent becomes positive. So the only thing we would do now is 5 squared means 5 times 5, which is 25. B to the power 8. There's the final simplified answer. What's wrong? What's wrong, Jen? What part are you confused by? The 5? Of the 5? Well, you have to raise everything inside the bracket to the power -2, which is, did I do something wrong? Sorry? I can't hear you. But it's a negative exponent, not a negative number. It's 5 to the -2. That's not a negative number, that's a negative exponent. Right? It's not -5, it's 5 to the -2. If it was -5, then absolutely it would stay, because that's a negative number. But 5 to the -2 is not a negative number. It's 1 over 5 squared or 1 over 25. That's a positive number.
So if the exponent is a negative,
Yes.
and it's the power of a number 5.
It doesn't matter if the base is a number or a variable, a number or a letter. If the exponent is negative, you have to make it positive by moving it from either the top to the bottom or the bottom to the top. Okay, let's look up above. What are you wondering about? Like in question 11, the -8, that's a negative number. That's not a negative exponent, that is a negative number. -8 is left of 0 on the number line. It is a negative number, and that's no problem. There's nothing you can do to change that. I haven't changed any of the rules that I've taught you. Haven't changed anything. But 5 to the -2 is not a negative number. It's a number with a negative exponent.
So then does that mean that 5 to the -2 is 1 over 5 to power?
Absolutely.
Oh.
And that's what I did. It went from 5 to the -2 on top, if I underline this right there, to 1 over 5 squared right there. Yes, Princess? Sorry? By subtracting 0 and 1. When you divide the a's, you subtract the exponents. So it's a to the 0 divided by a to the 1. 0 minus 1 is -1. I haven't changed anything that I've taught you. I'm following exactly the same rules that we established yesterday. Okay, and that's fine. Okay, are there any other questions on this? Well, you will, and we'll do more practice. But again, I haven't changed anything that I told you yesterday. I'm following exactly the same rules. Nothing's different. Okay, number 16. In this case, there's nothing that we can do to combine anything, right? You're not multiplying powers, you're not dividing powers, you don't have one power raised to another, but we have some negative exponents there. So the only thing we have to do is make the negative exponents positive. So Cherry, what would we do? Okay, that's a negative number, right? Not a negative exponent. So the -5 is fine, right? It's not a negative exponent. Right, that's what we do. And at the same time, what's x to the 0? 1. So negative 5 times 1 is just negative 5. That'll stay on top. The y will move to the bottom. The z, did you say z? Are you an American? That's what they say in the US. They don't say z, they say z. Must be lots of Americans in BC. Do they really? Yeah? Okay. Yeah. Okay, there's your answer. So again, that 5 is a negative number. There's nothing we can do about that. Nothing we need to do about that. It stays negative 5. All right, question 17. In this case, we can simplify inside the bracket, Keen. So how do we divide r to the negative 3 by r to the power 2? How do we divide r to the negative 3 by r to the power 2? What do? Subtract what? Say again? So what's negative 3 take away 2 equal? Yeah. And what about the t's? What do we do there? And get what? 4 take away 2 is 2. So there's step 1. Now what, Liam? Well, you need to pay attention because that would really help. So then you need to come in and get help. I'm here every morning by 8 a.m. I'm here for the first half of lunch. But sitting there and not paying attention and not trying to understand will not help. You need to take responsibility for your education. Okay? I believe you can do this. I taught you last semester. But you need to do your part. Okay? So had you done that assignment yesterday, that would have helped. Because what we did yesterday, we're doing the same thing today. That practice would have helped. I'm not going to argue with you on that. It takes time. Okay? And I know some people have more difficulty with math than others. That is a fact. No getting around it. Right? But I believe you can do this, but you have to work at it. And some people have to work harder than others to get it. Right? Maybe you're way better at English and social, writing essays than some people, where maybe they're better at math. That's just the way we're built. Right? And I know some of you are wondering, why do I have to learn this? I'm never going to use it. And the answer to that question is, you're right. You probably never will use it ever after you're done high school. But what you have to realize is that the purpose of school is showing somebody that you have the ability to learn. That's what school is all about. When you graduate, that diploma means something. It means that you have the ability to learn. So if you're going to go on to a college, they're going to want to know that you can be taught something. If you go apply for a job in the oil field or wherever, they want to know that you can be taught a skill. They want to know that you will learn what you've been taught. You will do what they tell you to do, not because you enjoy it, but because you need to in order to achieve whatever you're trying to achieve. That's the purpose of school. Okay? So come and get help if you need it. That's what I'm here for. And I mean, not just you, but anyone else that didn't get that assignment done yesterday, if you were stuck on something, then you should have come and seen me today, either this morning or at lunch, to get help so that you could get the assignment done and hand it in. And there's going to be more assignments. I'm going to be taking in at least one assignment a week for marks. If you're stuck on any of those, you need to come and get help. You can't leave it and let it snowball. And I'm not talking to you directly, Liam, because you're not the only one that didn't get your assignment in. Okay? So for everybody, if you need help, come and get it. Keen, what do we do next? Yes, multiply the exponents and the base stays the same. It gives you r to the 15th. Same thing with the t's. You're going to multiply the exponents. Base stays the same. 2 times negative 3 is negative 6. Put the t to the negative 6 on the bottom, and it'll become t to the positive 6. So there's the final answer. Yes, sir. We're almost done, okay? Question 18. We're going to work inside the brackets first by dividing the v's. And when you divide power to the same base, you subtract the exponents, keep the base the same. 2 minus 0 is 2. Same thing with the w's. You're going to subtract the exponents. Negative 3 take away 1 is negative 4. And that's all raised to the power negative 1. In the second set of brackets, again, deal with what's inside the bracket. Divide the w's by subtracting the exponents. 3 minus 0 is 3. And when you subtract the v's, yes, Kenzie? Oh, thank you very much. Better? Okay, so now when we divide the v's in the second bracket, you're subtracting the exponents. Negative 4 minus negative 4, the minus minus becomes a plus positive. It'll be negative 4 plus 4, which is actually 0. You're going to get v to the 0, which is 1. The other way of looking at it is you divided something by itself. V to the negative 4 is being divided by itself. Whenever you divide something by itself, the answer is always 1. So no matter which way you look at it, you're going to get 1 there. So I wrote v to the 0 there, but we can actually disregard it because that means 1 and w cubed times 1 stays w cubed. But in the first bracket, you have one exponent raised to another, so you multiply the exponents. And that is not negative 8. That is positive 8 because it's 2 times. Oh, I'm sorry, it is negative 8 because it's negative 4. But for the w's, when you multiply the exponents, negative 4 times negative 4 is positive 16. And then for the second part, you're just multiplying the 3 and the 2 together and getting w to the power 6. So the v in the first part is not being multiplied by any v in the second part, so it's not going to change. It stays negative 8 for now. But when you multiply the w's together, you add those exponents. 16 plus 6 is 22. Again, we're just using that basic law. When you're multiplying powers with the same base, you add the exponents and keep the base the same. And finally, you need to make the negative 8 exponent a positive by moving it from the top to the bottom. And there's the final answer with positive exponents. Some of you are probably getting sick of this because I'm doing the same thing over and over and over again, but repetition helps you remember. It really does. Okay? Seeing all these different scenarios, they all look different to start with, but we're using the same rules over and over and over again. The repetition will help you remember. Emil, what do you think the answer for number 19 is? Answer. I'm sorry? If you need a minute, absolutely. Take a minute. Okay, Jensen, you can go to the bathroom real quick, okay? I can see you starting to cross your legs there. We don't want any accidents. Make sure you sign out. Yeah. It doesn't matter what's inside the brackets. It's all raised to the power 0. Anything to the power 0 equals 1. Right? It's all inside the bracket to the power 0. It doesn't matter what is raised to the 0. The answer is 1. All right, we're looking at number 20. Again, that middle part is raised to the power 0. So this whole thing is really 1. And multiplying by 1 changes nothing. So we can forget about that middle part. Keen. Leave Princess alone. She's like my third favorite student. No. How far do you think you could count if you were counting and you started today? How far do you think you could go? That's where you are on my list of favorite students. I'm joking. I'm joking. I'm done. I'm blocked. Oh boy, my little plan worked. I'm joking. You know that. Okay, so that middle part is just 1. Timesing by 1 changes nothing, so we're just going to work with the other parts. There's nothing inside this bracket that we can do, so we have to raise everything inside the bracket to the power 3 outside. So that includes the 2 is raised to the negative 3 outside. The k cubed is raised to the negative 3 by multiplying the exponents and get k to the negative 9. The L to the negative 2 is done by multiplying the exponents. Negative 2 times negative 3 is positive 6. And same thing with the last bracket there. Everything inside the brackets raised to the power negative 1 outside, which includes the negative 2 coefficient. The k, you multiply those exponents. 3 times negative 1 is negative 3. And the L, you multiply those exponents. Negative 4 times negative 1 is positive 4. So we do have to deal with the 2 to the negative 3 and the negative 2 to the negative 1. We will have to deal with those because those are negative exponents. But before we do that, let's multiply the powers together that have the same base. We can multiply the k's together and we can multiply the l's together by adding those exponents. So I'm going to leave the 2 to the negative 3 as it is for now. I'm going to leave the negative 2 to the negative 1 as it is for now. I'm going to multiply the k's and the l's together. When you multiply the k's, you add the exponents and keep the base the same. When you multiply the l's, you add the exponents and you keep the base the same. Now I will deal with the negative exponents. I will move the negative exponents from the top to the bottom. The L to the 10 will stay on top. It is the only part there that has a positive exponent. So it's going to stay on the top. Everything else will move to the bottom. And when you do that, the exponent signs change from negative to positive. So on the bottom, 2 to the power 3 means 2 times 2 times 2, which is 8. Negative 2 to the power 1 stays negative 2. And I've got the k to the 12. The last thing I would do is I would multiply the 8 and negative 2 together to get negative 16, k to the 12. And again, a negative number is fine. That's not a negative exponent. A negative number is fine. It stays that way. We leave it there. There's nothing we need to or can do. Can't hear you. No, because we moved it from the top to the bottom, so the power became positive. Okay? Okay, I think we've done enough. I'm going to stop there. For practice, I'd like you to work on page 169 to 170. Just questions 4 and 5. So again, I told you guys this at the start. The expectation is that you do these questions. I'm going to post the solutions on Google Classroom so you can check your answers. But you need to do the practice. Okay? That repetition is going to help you. You have a quiz coming up on Tuesday. If you want to do well in the quiz, you got to stay caught up. You got to do the work. Check your answers on Google Classroom. You'll see step by step how it's done. If you have any questions, come and see me. That's what I'm here for.
169 and 167. This is 69.